All right, so this video is to introduce covalent bonding. So I put the periodic table here so you can, it's to remind you of where the metals are located versus where the non-metals are located. All right, so we discussed previously that ionic bonding happens between a metal and a non-metal, and I'll use the same color code here. So it happens between atoms that are metals and non-metals. Okay, and what happens here is the electron from the metal gets transferred to the non-metal, so he ends up looking like this. Right? One has a positive charge, the other one has a negative charge, and they attract, similar to like a magnet. You can think of it that way. They attract and they kind of stick together. And they kind of stick together like a magnet would. Right, so that is ionic bonding. Covalent bonding happens between nonmetals. And so you have two nonmetals. Okay, you have two nonmetals. And because they have similar electronegativity, there's no way of one pulling the electron from the other one. So instead, they share those electrons. So instead of a transfer that happened in ionic, there's actually a sharing of electrons. So the electrons here are shared. Okay, so that's kind of shared electrons. So that's the premise of covalent bonding. All right, so before we go any further into covalent bonding, I need to go over with you Lewis dot structure. So that's something new, Lewis dot structure. And just like with everything else in this class, it begins with the Bohr model. Okay. So I created a Bohr model for 3 atoms. I created a Bohr model for lithium, a Bohr model for fluorine, and a Bohr model for oxygen. A Lewis dot structure is nothing more than just an abbreviation of a Bohr model. So the Lewis dot only focuses on valence electrons. Okay, so you only focus on valence electrons. In other words, you only focus on outer electrons. All right, so to create a Lewis dot structure, what you need to do is you need to think of an atom. Okay, this is how you draw it. Think of an atom. It doesn't matter what it is. I put X and I'll show you some examples. Think of an atom as like an X, and you're going to place the valence electrons top, side, bottom, side. Okay, so you're going to kind of go into a circle, but pretend that there's a box around each atom. So let's try a few of them. Let's go first for lithium. Here's lithium. Okay, lithium is right there. So I'm going to start placing the valence electrons. It only has one, so that's an easy one. So this is the Lewis dot structure for lithium. Let's try fluorine. Fluorine, as you can see, has 7 valence electrons. So let's place them. So here go 1, 2, 3, 4, 5, 6, and let's see, there's 7. Okay, and 7. All right, so this is the Lewis dot structure for fluorine. And then the last one would be oxygen. So here's oxygen, and there are 6. 1, 2, 3, 4, 5, 6. So it might seem that I'm being a little picky on how to draw those things, but it will be very, very useful later on why they're drawn the way they're drawn. Right, so that's what I kind of wanted to talk to you about. So now we can start looking at the worksheet that you have it in front of you. And let me open this up. I need, I guess, this. All right, so this is the worksheet you have in front of you. And the first thing that asks you is determine the number of valence electrons from common nonmetal atoms. Create Lewis dot structure for nonmetals. So we just did that, but I'll show you some more. So we have like black king. Let's see, common nonmetals. So you have oxygen, you have nitrogen, you have hydrogen. Let me think of fluorine. We just did that. And probably one of the most important ones, which is carbon. Okay, that's some common Lewis dot structures for some nonmetals. There are two important words that you need to know. So let me take a nitrogen, for example. Okay. So those electrons, they actually have a name. So this pair of electrons right here is called a lone pair. Okay, it's called a lone pair. And then each single one of those are called unpaired electrons. And you might wonder, why is that important? Well, the bonding will happen with the unpaired electrons. So this one, and this one. That's where the bonding will take place. So if you can think of it as a jigsaw, those three unpaired electrons are the ones that are going to connect to the other pieces. The lone pair, you're going to leave it alone, is already paired up, is not going to take place. It's not going to have an effect on bonding. All right, then the second question is, what is covalent bonding? Well, is the sharing of the electrons, and I'll show you how they share in a moment, but it's the sharing of electrons between nonmetals. This is going to be important for you to know. Okay, it's between nonmetals. And in order to reach a full orbital, so same business as ionic bonding, they will bond so they can have 8 valence electrons. Okay, in the outer shell, with the exception of hydrogen, excuse me, that will have 2 valence electrons, and that is hydrogen. Okay, so hydrogen is the only exception, at least for nonmetals. All right, so there is such a thing as a single, a double, and a triple bond. Actually, what I would do, I think it makes more sense for me to show you some of the bonds, and then I'll go back to this one. So let's see how hydrogen bond. All right, so this is the example of hydrogen. So the hydrogen that's in the air, and actually the fuel, hydrogen is actually a fuel, it doesn't exist by itself. It actually exists bonded to itself. So this is what it looks like. So this is, I don't know what just happened. Okay. Okay, this is one hydrogen. And then I'm going to do another hydrogen of a different color. I'm not quite sure what's taking place here. Okay, so hopefully you can see it. Or maybe I can just pick it up like this. Oh, I know what's taking place. Never mind. Okay, those are your two hydrogens. So what will happen is they will come together. Let me do the black one over here. They will come together and share these electrons. And if I'm going to write it, I would write it like this. Okay, and the formula, this has a formula as well. Okay, the formula would be H2. Okay, and this is a pair of electrons. Remember, for hydrogen, because it's small, it has a full orbital, one has two valence electrons. So those electrons are being shared between them. All right, let's look at another example. Okay, so this is the formula. So let's look at formula. Okay, the formula is H2O. That's your water. All right, so the Lewis structure for each one individually. So you have oxygen. Okay, this is oxygen. It has two unpaired electrons. Those are the ones that are gonna hook or they're gonna bond to something else. And then you have two hydrogens. How convenient. Okay. When they come together, let me make the hydrogen electrons different colors so you can see. This one would have red, and this one would have a yellow. That way you can actually see what I'm talking about. All right, so oxygen comes in. And then one yellow from this hydrogen and one red from this one. Okay, so they're being bonded here. Okay, and there's another bonding happening here. So if I'm gonna draw the structure, it's gonna look like this. And this is your classic structure of water. So now let's go back to that other question. And by the way, if we're looking over here, I forgot to mention this. This hydrogen, okay, this hydrogen over here has two electrons that are being shared. This one has two electrons that are being shared. And oxygen has 8 electrons that are being shared. So 2, 4, 6, 8. So everyone is happy here. Everyone has a full orbital. Right, so differentiate between single, double, and triple bonds. So all the examples I gave you were single bonds where two atoms are sharing a pair of electrons. We call single bonds. There are other cases where you see later on where two atoms can share two pair of electrons. Okay, if I was going to draw a single bond, I would draw it like this, A and B. If I was going to draw a double bond where there's two pairs being shared, I would do A and B. And then if it was a triple bond, there's some compounds that have triple bonds, and it looks like this. So there's actually there's 3 pair of electrons that are being shared between them. Okay, so all the examples here, like this one, is a single bond. So is this one. See here, single bond and single bond. So I haven't showed you any double bonds. You're going to see that on the next activity. All right, so now let's move on to the next activity. So you're going to click on this link where it says Game Challenge right here. Okay, and you're welcome to work with somebody else, but let me walk you through. So you're going to do 3 things when it comes to that game. You're going to do this one. you're going to do the single bond, you're going to do the double bond. Unfortunately, they don't have triple bonds, but you're going to see that later on. And then towards the end, you're going to create 3 new molecules. Okay, and those molecules, I'll leave it up to you what you want to create, but obviously it cannot be any of those that you already have created previously. When you create those molecules, here's some rules for the game. Pretty much everything I already mentioned to you about the octet rule and what is the objective. All right, so for each molecule that you create, you're going to do 2 things. One is you're going to draw the structure, okay, this structure over here. Well, not with the circles. The circles was just me explaining to you. And then you're going to tell me how many lone pairs is in the central atom. And the one thing that I need to mention to you is that the central atom is going to be the one that can make the most number of connections. Oops. Okay, just like a puzzle piece, you're not going to put in the middle something that can only make one connection, right? So for example, the oxygen and the hydrogen, each hydrogen can only make one connection. There's only one unpaired electron, whereas oxygen can make 2 connections. That's why that kind of went in the middle. So you put in the middle the one that can make the most connections. Okay. Usually people also say the one that's least electronegative. Okay, so that's another way of saying it. All right, so you're going to be drawing the molecules that you create here, here, and then here. And that is the plan. And then we're doing this another time. Okay, but this is our goal for today. All right, so you click on this link and let me get you to that activity. Okay, where is it? I think it's, nope, it's, forget about that. I don't know what it is. All right, so you press start, and then you're gonna go for the single bonds. Remember, I told you you're gonna do single bonds, you're gonna do double bonds, and then you're gonna do free play. So double bond, and then just pretty much read the instructions. The first molecule you're gonna create, it's methane, is CH4. Okay, so that's the formula. You press OK, and then again, just read the instructions. It's in pink. Is asking you to drag out carbon atom to start building the molecule. So I drag out carbon, and then it asks me, and again I'm reading what's in pink. You need to bond 4 hydrogen atoms to carbon, so to make a CH4. So let me get 4 out. 1, 2, 3, 4. All right, so notice how each hydrogen can only make 1 connection. Carbon can make 4 connections, so it makes sense to put carbon in the middle. All right, so here comes the connection. If you double tap on it, you can rotate. Okay. What you see over here, this moving image, is actually the 3D version of the structure that you created. Okay, and we are going to put that into your notebook. Not in your notebook, excuse me, on the worksheet. Let's go back there. Okay, so this is your first molecule, is a CH4. Okay, and we draw it as CH4. All right, so that's your first molecule, and I should have made into a table so you can separate them out, but you can separate them out. Note that if they have lone pairs, make sure that you add lone pairs to it. All right, so you're going to be doing this for all the other molecules, and then let me know if you have any questions.